Okay, so as you may already feel, we have to do grid searches for the Gaussian kernel as well. Well, but the good news is we only have two hyperparameters. We have the C and the gamma, and then of course we have to specify the kernel is it's a Gaussian kernel. Okay, so well, to do a grid search, and we still have to specify the parameter grids, and those are the search space we want to do. And after that, we create a SVM SVM model, and then we send the hyperparameters, and this research will exhaustively try all the combinations for us and tell us what is the good hyperparameter combination. So eventually I got this one. So C is the highest value, so 100, and gamma is 1. So if you see my search space, so gamma is, well, 101 or 0.01. So gamma is right in the middle. So probably I would love to take that. However, the C is 100. So C is, well, it tells me the largest C is the best. Okay, so if you go up here, so for the higher C, and you may find for the higher C, well, even for the higher C combined with a low gamma or a medium gamma, this plot doesn't make too much sense for me, because here, so why we are so confident this area is blue and we don't really have any samples over there, right? So, well, I wouldn't say I want to go even higher with the C. I would say I would, well, it says the research says C, the best C is 100. Do I want to try 500 or 1000? I would say I don't want to try that. However, if I do want to do the next research, I will do slightly lower C, like how about 50? How about 20? And then for the gamma as 1, and this is already a medium gamma, I could try, say, well, how about 5? How about 0.5? Well, those are the values I may want to try, but the point is we shouldn't really go extreme and try the very low or very high C or gamma. Okay, so the next part we are going to load the cancer dataset again, and we want to do one grid search. So for the first grid search, and remember we say we usually want to do a very coarse grid search. So for this one, I try the C is 0.01, and then 1 and 100. Okay, and the gamma I try the same thing. So I didn't really give the grid search a lot of values to search. So I try a first coarse run of the grid search, and then if the first grid search help me narrow down the possible search area, and then based on my understanding of the hyperparameters, and then I will try the second round of the grid search. So in this part, well, you should do something similar. Do a very coarse first round of the search, and then if it narrows down and give you some of the idea, and then based on well, for example, this is what I got, and based on your understanding of the hyperparameters, then you can try to change your strategy and then do second round of the grid search. Okay, so I did two rounds of the grid search and then find a combination of the hyperparameters, and of course for this gamma it is small enough, and I don't want to make it even smaller, of course. And then I try the performance of the best model, and it looks good to me. So, and go ahead and write your code, and I will well, I will still use the same video, but I highly recommend you to pause your video for now before you see my solutions. Okay. Okay, so this is my solution. Well, in the first grid search, I tried C is 0.0001, and then 0.1, and then 10 and 1000. Okay, so at the in the middle of this lecture notes, we say we rarely do the searches lower than 10 power negative 3 or higher than 10 power 3, which is 1000. So I use this as the search space, and for each of the parameters, and they are 100 times higher than each other. So well, this one, and then I try this one, and then I multiply by 100, and that is the 0.1, and I multiply by 100 again, that is 10, and multiply by 100 again, that is 1000. Okay, those are the values I'm going to try, and the point is I want to do a very coarse grid search, and I got a C equals 10. Well, and that is a medium C, and then for the gamma, that is a really small gamma. Okay, so if I want to try the next grid search, I would like to do, how about C is 1 or 100? I would like to try those values. And for the gamma, do I want to go even lower than that? And I would say I don't want to. So I tried the 0.001 and also the 0.01. So I want to try those gamma values and see which one works better. And I did the second run of the grid search, and I got the C equals 10. So remember, the first run I got C equals 10, and then the second run I still get C equals 10. So probably C is 10 it is. And for the gamma, well, the grid search still says the smallest gamma is the best gamma. So I would say I'm going to take that. However, I don't want to try even lower gamma values. Okay? And if you want to try something different, so for example, like the gamma, how about you try 0.5, 0.008? Well, go ahead and try them, and well, they may work a little bit better. Okay, so and after that, I use the you can simply use the grid to do the prediction for you, because by default the search grid will use the best model. Okay, and then I got the performance, and I think the result, I'm gonna happy with the result for now. And a very quick sum up for the RBF kernel, or the Gaussian kernel. Well, the trick is we are going to draw the Gaussian curves on the top of all the samples. So remember, this is computational expensive. And if you have thousands or millions of the samples in your training set, well, before you try the Gaussian kernel, you should try to do a sample first and keep a reasonably small sample of the dataset before you do the Gaussian kernel. And then, well, you definitely need to do a grid search. And remember, the rule is if you do a very low gamma and a very low C, and then you will have a under-fitting model. And on the other side, if you want to do a very high gamma and very high C, and you get a overfitting model. So for the overfitting model, you only learn from the existing samples. You don't learn the whole structure or the whole big picture of the distribution of those classes. Okay, so do grid searches and try to get a reasonable combination of the hyperparameters to guarantee the best performance of your SVM. Okay, so that's it for today, and I will see you guys tomorrow.